Okay. Okay. So I think you have sent the value, no? Okay. So I think this is correct. Okay. So you can see that 2 volt, the value is we can take 1.75 volt. Okay. And for 3.1, we can get 3.5, no? Okay. And 3.6 also we can get 3.5. We can quantize it to 3. And 4. I think it is better to take 4.75 volt. And 4.8, here you have 0.5, and here you have only actually not 0.5, you know, you have 4.3. But here you need, what is the value? This one or this one? Okay. I hope it is 4.75 may be okay, no? Okay. So 4.8 also, you can use 4.7. Okay. And 5.9, you can use 6.126. Okay. You can use 6.126. Okay. So what you have done there? Okay. So you can see that. Okay. So we have a analog signal like this. Okay. And you sample it. Okay. You sample it and you can get some sample value like this. Okay. You can get some sample value like this. Okay. So here you have get 3, okay, and you get 2 volt, and you get 3.1, okay, and you so here you get 0, okay, and you get your discrete signal is like that, no? Once you have quantize, it is somewhat like this, no? Okay, not quantize, sample. Okay, so this is the sample signal or discrete time signal. Okay, so this is our original signal, and it is the analog signal, and as well as it is a continuous time signal. So in sampling, we have convert this CTS into a DTS signal, discrete time signal. Okay, so you have some voltage value, maybe 0, maybe 2 volt, okay, maybe 3.1, okay, and maybe 3.6, okay, and maybe 4, okay, and maybe 5.9, okay, and this may be 4.8, okay, and this may be this may be 3.5, we don't know, 3.5, this may be this may be 2 point, what is that value? 2.625, we don't know. Okay, so this kind of signal we can get. Okay, so this is the sample signal. Then we have to quantize this. Okay, so here we are doing the sampling. Okay, so what is in sampling we are doing? We are changing this continuous time signal into discrete time signal. Okay, so this is the sample. Then we are doing the quantizing. In quantizing, what we are doing? We have some voltage levels. We have to convert them into the encodable voltage level. Okay, encodable voltage level. Okay, so what is that? Okay, so again you will have a discrete time signal, but these voltage levels are change different. Okay, so for example, you have to approximate this 0 to 0.875. Okay, so this will be 0.875, and this 2 volt you have to convert it to 1.75. It is 1.75, and this 3.1 you have to convert it to 3.5. You have to convert it 3.5. Okay, so you can see that this is quantized. We have reduced the voltage level. Okay, and for this one we have increased the voltage level, and again this one we have reduced. Okay, so likewise you can increase and reduce the voltage level of the sampled signal to get the encodable voltage value. So that will be the quantized signal. Okay. So this will be 3.5, and again 3.6 also will be 3.5. Okay. And you have 4 here. For the 4, you can have 4.37. Okay. And that value will be 4.37. Okay. And I will write it here. Okay. So this can be max put to 3.57. Okay. So this 5.9 you can approximate to 6.126. Okay. So this is 6.126 like this. Okay. And this 4.8 you can again convert it to 4.37. Okay. So again you have 4.37. So you have reduced. This is 4.37. Okay. And this 3.5, you can use the 3.5, no need to value, because 3.5 is the encodable value. And this is 2.625. That is also encodable value. So you no need to change. So this is the quantized signal. Okay. Then after that, you can assign. So these are encodable value. Then you can assign the voltage levels. Sorry, you can assign the bits for that one. Okay. For example, for 0.75, you can assign 000 value. Okay. For 2 volt, that is 1.75. You can assign 001. Likewise, you can assign the values. Okay. So actually, that is the process of the ADC, analog to digital converter. Okay. Is this clear? Okay.
Yes, sir.
Okay, thank you. Then, so you can see that this is the number of bits we are using to represent a voltage level. Okay. So in this example, we use 3 bits to represent our. Here we use 3 bits to represent our voltages, to represent our voltage level, Okay. Actually, this is called the resolution of the ADC. This is the resolution of the ADC. This is resolution of ADC. So if you can see, if you can get the ADC, and if you see the specification, the one most important specification is this resolution. So what is the resolution means? That is the number of bits we used, or that ADC is used to represent a voltage sample, voltage value. Correct? So that is the resolution. Okay. So this is very important parameter. Okay. Another very important parameter is the range, input range of the ADC. Input range is the minimum voltage and maximum voltage you can get. Okay. So normally it is maybe 0 to 12 volt, 0 to 5 volt. We don't know any range. Okay. And please remember that the ADC can't sample minus voltage. Okay. So minus voltage. So the range will not be a minus value. It will be a plus value from 0. Okay. So range will not be a minus value. Okay. Minus value. Okay. Because minus voltage value cannot be converted into a digital form. Okay. So you have to keep remember that part. Okay. So ADC range is always from 0 to other value. Okay. So these are the most important parameter of the ADC. Okay. And also there is a bandwidth also. Bandwidth. Okay. Bandwidth means the range of frequency. That is ADC can support. ADC can support. Okay. So these 3 bits. Okay. So this is the resolution. Okay. Number of bits to represent a voltage value. So this is the input range, maximum and minimum voltage, maximum and minimum voltage values that can be encoded by a ADC, and bandwidth. This is the frequency range of the bandwidth. Okay. So this is depend on the maximum frequency that can be sampled by the ADC. Okay. For example, Arduino board have the ADC inside. It can support up to 9.8 kilohertz, as I can remember. Okay, you can count this value. Okay, check in the internet. Okay, how to count this? Okay, so these are the most important parameters for the ADC. Okay, so I will give you one example again. Okay, so try to do this by yourself. Okay, I will come back. Okay, so don't leave. If you have any other work, you can do. No issue. But try to do this exercise. Okay, so this is exercise 2. Now I use this value. Okay, so so you have ADC. Okay, let's say that 4-bit resolution, 4-bit ADC, 4-bit resolution ADC. Okay, and input range is 0 to 5 volt. Okay, so can you find what are the voltage values this ADC can encode? Okay, then what are the bit combination for these voltage values? So can you find this? So this is also very easy. Okay, so this kind of things you should be able to do. Okay, so what you have to do is, okay, so do this as a homework. Okay, so next week if you have any problem you can ask me. Okay, and what you have to do is the range is 5 to 0. Okay, so 4 bits means, okay, there are 4 bits, and that means 2 to the 4 you can get. Okay, so this is the resolution 60. Now I will get 7 value here, 7. Okay, just take it, the input range is 0 to 7. Okay, so the input 7 minus 0 divided by 16. This is the minimum value. Okay, so can you tell me what is the minimum value, please? It is 7 divided by 16. 7 divided by 16. What is that value? Please tell me. Okay, it is 0.4375. No? Right? 4375. So this is the minimum value. This is the minimum value. Minimum value you can represent. Okay, so you have 16 combination like this, 0 0 0 0 1 0 0 1 0 like this. Okay, 0 0 1 1 like this. You have 16 combination. Okay, so this you can represent using 0.375 volt. This one you can represent the double of this one. Okay, that is maybe this one 0.8750, and this can be again you have to add 4.35. Okay, so likewise you can find the voltage values and the bits. Okay. Now tell me which ADC is the good one and why. Okay. So this is you can easily find. Okay. So example 1, we get 3-bit resolution ADC. Okay. And example 2, we get 4-bit resolution ADC. Okay. And the input range is same. Okay. So which one is the good one? And tell me why it is good. Can you tell which one is the good one?
Second one.
Yeah, second one. And why the second one is good?
Minimum range values.
Yes. Yeah. So here you can see that minimum voltage value is 0.735. The other one is this one. No, this is the minimum readable encodable voltage is 0.75 for this one, 3-bit resolution. But 4-bit resolution, you can encode this one also. Okay. So if you try to reconstruct, try to sample, try to convert a signal using this ADC, okay, so you will have some value. The separation should be 875. Okay, the voltage separation should be 875, but here voltage separation will be 4.375. Okay, here the voltage change is very small. Okay, so once you reconstruct the signal, you can get a smooth signal rather than this one. Okay, rather than this one, you can reconstruct or you can get a very accurate signal. The accuracy is more than this. Okay, so when the resolution is high, you can get the high accuracy. Okay, so normally in Arduino, you have 16-bit ADC. Okay, so the resolution is 16. Okay, so 2 to the power 16 voltage level you can get. Okay, okay. So have you interface any? So there is an Arduino. No? Okay, there is an Arduino board. Okay, if there is an Arduino board, if you if you want to decode analog signal, okay, you have to interface it with the analog pin. Okay, there are some analog pins. Okay, okay, let's say that you have connected so this is additional things. Okay, maybe you have seen this in when you are doing the designing project. Okay, so these problems actually have the final year student also have these kind of problems. Okay, so if you connect if you connect what is let's say the temperature sensor to the analog input. Okay, now using a serial port. Okay, using the serial port, you are checking the value of this AC. Okay, and you can see that you can get many values. Okay, you can get many values, many big values. Okay, so this time so let's say that this temperature will give you 0 to 7 value. Okay, 0 to 5 voltage, up 0 and 5 voltage. Okay, but here you can see some 405, 403.5 value, 203.7, 16.7. Likewise, very big value you can see. What is that? Why is that? You think why is that? හිතා ගන්න පුළුවන්ද මාළක? ඇයි එහෙම පෙන්වන්නේ කියලා? දැන් මේක පෙන්වන්න නැත්නම් ෆයිනල් ඉයර් කට්ටියමත් මෙතනදී පොඩ්ඩක් යන ගන්නවා. ඇයි මෙහෙම කියලා? Maybe still you are not working with this equipment, no? So you can't imagine. Okay, that is okay. Actually, that is happened because the resolution is 2 to the power 16. Okay, so that means 16 bits you can use. Okay, So there are some value, okay? Actually, it get the decimal value, okay? So if some voltage is here, it will show you the 0. And if the voltage value is here, if it will show you the 1, okay? Likewise, you will see this, you will see this decimal value. The last decimal value you can see is like this, okay? So 16,000 values are there, actually, you can see, okay? Okay, so actually this happened because these are just, it show just the decimal value, okay? Then to see the actual voltage level, you have to map this, okay? 0 to 0, 0, 0, and 5 to 1, 1, 1, 1. Okay, likewise, you have to map. Then you can get the voltage value between any. Okay, so if I have the time, I will show you in the Arduino. Okay, so maybe when you are doing the final year project, you will see this. Okay, then remember this and try to find the solution. Okay, if I have time, I will try to do this in our next cell. Okay, so that is it. Okay, so you can see that if you have ADC now, if you have ADC, if you given a signal, okay, if you given a signal, analog signal, you will have some bits actually. You will have some bits. Okay, so you will have some bits like this. Okay, and so that is the immediate output. You will have the bit stream like this. Okay, parallel bit stream, but you can convert this parallel bit stream to serial bit stream. No issue. Using the multiplexer, you can do that. Okay, so there are some ADC. Okay, there are some ADC. The input is serious. Input is serial input normally. Okay, but output may be serial or parallel. Okay, serial or parallel. Okay, and also if you consider a DAC, okay, if you consider a DAC, okay, the analog to digital converter, what happened that, okay, what is happening at the DAC? Now I think you can see, okay, so you will get some this kind of signal, no, okay, this kind of signal. So these are 0 and these may be 1, okay, 1 and 0. So you have to give 0, 1, 0, 1, likewise some bit stream encoded signal. Then the output will be a voltage one. So using a DAC, if you consider that, it is normally a parallel to serial. Input is parallel and output is serial. And you can also convert this to a parallel input using a demultiplexer or something. Okay, like this. 1 to 8 demultiplexer. Okay. Then you have input also serial and output also serial. Okay. So that kind of ADC and DAC may be there. Okay. ADC and DAC may be there. Okay. So that is the thing you should understand up to this one, how the ADC happened and how the DAC happened. Okay. So we will see the implementation. Okay. So we will stop here. Okay. And try to do this example by yourself. Okay. I think already we have done it. You can do that. Okay. And so we will see the implementation of these circuits in electronics. Okay. So we will start it with DAC. Okay. Because DAC are simple to implement. Simple to implement. Okay. So we will start from here. Okay. So shall we stop? So do you have any